Alright, boys and girls, today we're going to look at position time graphs. Now, the big thing to kind of keep in mind when we're looking at position time graphs is that every graph is trying to tell a story. The story that this graph is trying to tell is what's happening with the position of a given object over a certain amount of time. Now, obviously, every single graph that we look at, you're trying to figure out what's going on in terms of the y and x axes. Your big key here is the fact that your vertical axis happens to be position. So we know that all that's changed is this position. We don't know anything about the actual velocity until we calculate the slope. Because in these graphs, your position time graphs, your slope equals the position, which is in this case going to be meters, and your time, which is in this case going to be seconds. And we know that when we've got meters per second, we are actually talking about your slope equaling velocity. And the velocity comes about because we can be moving position forwards as we move up, or backwards as our slope happens to be negative. Anyways, with that being said, we're going to work our way through this and start off in terms of segments like you would see on a test. I would call this thing segment A, this whole thing would be segment B, this would be segment C, and this would be segment D. And essentially segment A would exist from here to here. So what we're going to do is we are going to find the slope of this segment, and you do it by finding the rise over the run. And what that really means algebraically is we are going to solve for y2 minus y1 over x2 minus x1. Well, in terms of your y, because we're talking about the rise, you didn't have any change in rise. We started at 20 meters and we ended at 20 meters. So we are going to simply have 20 meters minus 20 meters. And in terms of our time, we're going from 0 seconds to 1 second. So 1 second is what we finish at, 0 seconds is what we start at. So we end with a 0 meters over 1 second. And again, 0 over anything gives you 0 meters per second. Now, what does 0 meters per second actually tell us? It means that whatever this is, and we could call it a ball, this ball is completely stationary. It is stopped. Now, where is it stopped? It is stopped exactly 20 meters from the start, or wherever it actually started. In terms of our second set here, now that we see that there is a change in slope, we know that the ball has started to move. The fact that the slope is positive means our ball is starting to travel forward. It travels forward from 1 second all the way to 3 seconds here. So we're trying to figure out the slope of this thing. So again, we set this up. y2 minus y1 over x2 minus x1. And I'm just going to kind of pigeonhole things in this setup. In terms of your x2 and your x1, we're going to start off, our starting time, our first x is 1 second. 1 second. Our finishing time is 3 seconds. 3 seconds. So we've got that guy, 3 minus 1 is going to end up giving us 2 seconds. And in terms of our y's, we started off at 20, y1, 20 meters. And we ended at 60. So we've got 60 meters. 60 minus 20 gives us a nice 40 meters. And so our slope for this whole setup is simply going to be 20 meters per second, which means you are moving at a fairly quick rate there, 20 meters every single second. Again, looking at position time graphs, we should get the idea that once we hit this 3 second mark, the entire slope completely balances out to a nice horizontal position, which means there is no change in position. We start at 60 and we end at 60 meters, which means this whole thing, you should at this point kind of realize that means if there is no change in position, this thing is stopped at 0 meters per second. And where is it stopped? It is stopped 60 meters away from the origin. So we're stopped at 60 right here. And so our final calculation is actually looking at this D segment from here to here. And so again, as always, we start off with y2 minus y1 over x2 minus x1. And I think the big thing that you need to consider when we're looking at this problem is the fact that we are starting to move back. And what this really means is because your slope is equal to the velocity and you have a negative slope, this negative slope indicates that we have a negative direction on our velocity. So this segment is the ball that we're talking about is moving back to the origin. It's moving from 60 back to 20 meters. Okay? So we're going to start off with, in this case, we'll start with time. And so we kind of sketch our way down, figure out what this is. Ooh, nice little decimal. So we've got 4.5 seconds there, and we go all the way to 6 seconds. Okay, so with that 6 seconds minus 4.5 seconds, we end up with the 1.5 seconds here. And what we end up doing from there is finding our y. Now remember, this is the one confusing thing because our initial is going to be big. We've got our initial is 60 meters, and our final is going to be 20 meters. Which means this whole thing, 20 minus 60, is going to give you a negative number, negative 40 over 1.5 seconds. And so throwing that into your handy-dandy calculator, you should end up with a slope of negative 26.67 meters per second, which means you're moving 26.67 meters per second in the negative direction. So in terms of which of these velocities is actually the fastest, this velocity is going to be the fastest because it's 26 compared to the 20 that we had here. However, this one happened to be in the positive direction. Your B happened to be in the positive direction, while your D happened to be in the negative direction, back to the origin. And if all of that makes sense, you should be in a very good place with position time graphs. So what we're going to do is we're going to work our way to the second example. A little more complicated, probably going to go a little more quickly. We'll get ourselves down to the second page here. But we're going to start off with this thing. And we'll zoom out just a second so that we can see a little more. But at this point, we should be able to, again, look at the fact that we've got a position versus time graph. So we know that whatever happens, your slope equals the velocity. And that is a big, big deal. So we know that if we happen to have a positive slope, this should be a positive velocity, which means you are moving forward. We know that this horizontal is a zero slope, which means you have stopped. We know this negative slope means that you are traveling back to the origin. Okay, back to start. Again, this horizontal slope means that you have a zero slope, which means, again, we stopped, and then we start moving forward again, and then backward again. And none of this has said anything about speed until we calculate the slope. And again, you calculate the slope by doing your very, very simple y2 minus y1 over x2 minus x1, otherwise known as rise over run. Now, in this case, I'm probably not going to write this out for every single one, but we will jump straight to what does this whole thing equal for our rise over run. And hopefully that'll make a little bit more sense in just a second. So we're going to start off with this first segment, and we'll call it A. So for A, we're moving from here to here. And in terms of what your rise over your run is to calculate your slope, your rise, your change in y, was from 0 to 8 meters. So we end up with a rise of 8 meters. And our run is simply going to be how much time was used, how much time passed for this moving thing. So if we're saying this person walked forward 8 meters, it took them 4 seconds to do it. So your run was from 0 to 4, so we have 4 seconds. You throw all that together into your calculator, or do a little mental math, and you should end up with 2 meters per second. And so in terms of your moving forward for part A, you are moving forward at 2 meters per second. Our second portion, we'll call this guy B. All right? B is working from there to there. And in this case, we know that we are totally horizontal. We did not rise. We did not fall in any case, which means our y2 minus y1 is simply going to be 8 minus 8, giving you a 0 over something. And realistically, it's a 0 over 6, but who cares what it's over? 0 over anything gives you a 0 meters per second, which is, again, stopped. Okay? Now, once we move forward 8 meters, walk forward for 8 meters, we stop for 2 seconds to hopefully not catch our breaths, because that means we're really out of shape. We're going to work our way back, going from 8 meters to 4 meters. So you're moving back in the same direction you came. Okay? And so what we're doing here is we're throwing together a nice little rise over run. Your y2 minus y1, x2 minus x1. In case of the x, we're talking about time, and we know that we are going from 6 seconds to 8 seconds. So that's going to be a 2-second time difference from 6 to 8, this little patch here. But your run is going to end up being that y2 minus y1. The y2, again, is your smaller number. This guy is going to be a 4 meters. This guy is going to be your 8 meters, which means 4 minus 8 gives you a negative 4 meters. Negative 4 divided by 2 means this whole thing is going to end up being negative 2 meters per second, which means we're traveling at the same speed both here and here, but the velocities are in the opposite direction. That velocity is signified by this negative sign here, and the lack of a negative sign there. Positive velocity means forward. The negative component on the velocity means that we are simply 2 meters per second, but traveling backwards. Okay. Again, we get to a change in the slope, and in this case, again, the slope is simply a horizontal slope, so we know there's no change in position. We start at 4, we end at 4, so this is going to be 0 meters per second. And now we finally get moving again, and we start walking forward for a second time. And so this walking forward takes us from, where are we here, at 10 seconds, to this mark over here at 14 seconds. So we walk forward a ways from here all the way to here. Okay, we'll call this guy, this was A, this was B, C, D. This thing is now E. So in terms of E, again, we are trying to figure out what's the y2 minus y1 and the x2 minus x1. Let's start with the y. Your y is, again, your change in position. So in our change in position, our y2 is going to be 8 meters minus 4 meters, all over the change in time of 14 seconds minus 10 seconds, which really comes down to 4 meters over 4 seconds. So the E is going to equal a very nice 1 meter per second, which means it is half of the speed that we saw in segment A. And that should make sense. That should make sense because when we actually compare the slopes, the slope of A is much more steep than the slope of E was. It's actually twice as slope, which is why you get a 2 versus a 1. And then our final segment is going to end up being segment, if we're at E, this is going to be F. And F is simply from this 14-second area to the 16-second area. So if we're doing our rise over run, or our y2 minus y1, x2 over x2 minus x1, I already know x2 minus x1 is our time, and that's going to be 14 to 16 is 2 seconds. And we end up going from 8 meters all the way back to where we started, so at 0. So we know we travel backwards 8 meters. Negative 8 over 2 gives us a negative 4 meters per second, which again is saying that you are traveling at 4 meters per second back to the start. Okay, and as long as you get that, we're probably in a very, very good place. Anyways, the next time we talk about graphs, we'll be talking about velocity versus time graphs.